I think it will be. Hello guys, welcome you all for this end-to-end session of AIML, where you guys gonna learn everything that you guys need in order to become a successful data scientist. Hope you guys are enjoying. We are enjoying a lot. We are learning a lot each and every day. Hope the same thing for you guys. If you guys stuck anywhere, if you guys have any doubt, just ping in the comment section. We'll take up and we'll solve your doubts as always. Okay. And before coming to the session, make sure you guys watch all the previous session videos so that you can have a continuation. Okay. And we are learning something which is gamified. Okay, reinforcement learning. We're gonna continue that. That is Markov decision process. Today we're gonna continue that. And before this session, make sure you guys subscribe to our channel because like every day we are just uploading a new video, guys. Okay, so whenever we upload a new video, we will be getting a notification, right? Whenever you subscribe and hit the bell icon. Okay, so yeah, without further ado, let's go into this session. So first we are having solving MDPs, dynamic programming. Let's see what it is. Okay, that is Markov decision process. Dynamic programming algorithms are commonly used to solve the Markov decision process by finding the optimal policies. This algorithm works backward in time, starting from the final state and iteratively computing the optimal value function for each stage. Okay, let's see how it is happening by using only two things: value iteration and then policy iteration. What is value iteration? This algorithm iteratively updates the value function until it converges to the optimal solution. It involves calculating the expected value of each state and the actions, and then selecting the action with the highest expected value. Policy iteration. This algorithm iteratively alternates between policies evaluation and policy improvement steps. It involves evaluating the current policy value function and then improves the policy based on the value function. I hope like it's very theory. Okay, let's make it simple. Okay, what is my value iteration? Okay, what is this process of dynamic programming in MDP? That is Markov decision process. This is simple. Okay, let's have the same Super Mario character, Super Mario game. We're going to start from the goal and we need to reach the start state such that each and every state should have a optimal actions so that we can reach the start state and start to final state without making any kind of in like obstacles during our way. That is called as value iteration. Policy iteration, what are the kind of steps that we're going to do, right? That is called as policy iteration. Value is like a consider it as a reward and from moving from the goal to start state. Policy is a set of rules that we need to follow in order to get the proper rewards or actions. That is called as a policy iteration. Okay. I hope like I have simplified the things. Yeah. Yeah, sir. Over to you.
Yeah, so solving MDP is dynamic programming. So guys, we have to we use dynamic programming for MDPs. So dynamic programming algorithms are commonly used to solve MDP by finding the optimal policy. So now, till now, you know what is the policy, and these algorithms work backwards in time. Okay, so because they have to learn from the past experiences, we've seen these characteristics, and starting from the final state and iteratively computing the optimal value function in each state. So there are two components to it. One is value iteration. So the algorithm iteratively updates the value function until the coverage to the optimal solution. It involves calculating the expected value of each state and actions, then selecting the action with the highest expected value. Then we have policy iteration. The algorithm iteratively alternates between policy evaluation and policy improvement steps. It involves involving the current policy value function and then improving the policy based on the value function. So we do value iteration, okay, wherein algorithm iteratively updates the value function until it covers the optimal solution. Then we have policy iteration, where the algorithm iteratively alternates between policy and evaluation and policy improvement steps. So these are very crucial, important steps, because the MDPs we learn from the past data and past experiences. That is the characteristics of it, and then these elements, and that make it very powerful. You already know that dynamic programming is very powerful because it has multiple dimensions. Like we can solve complex problems with this, and definitely when we learn from the past experiences and with such algorithms, we can make right decisions, and that's why MDPs are very powerful. Let's move to the other section.
Yeah, sure, sir. Okay, let's move on. Okay, reinforcement learning and MDP. Let's see what's the difference. Okay, yeah, reinforcement learning is closely related to MDP. It's true, right? Ancient method, it's a modern method. Reinforcement learning algorithm learns optimal policy by interacting with the environment and receiving the rewards. Agent learns to maximize its rewards by exploiting and exploring and exploiting the environment, updating its policy based on its experience. Both are same, right? So they're going to be state, they're going to be agent, they're going to be action. Based on that, it's going to get the rewards. Everything same. Okay, let's see. MDP assumes known transaction probability and rewards. Reinforcement learning learns transaction probability and rewards from the experience. Okay, this is what the difference. In MDP, it it is a mathematical model, so there are going to be lots of assumption. But like in reinforcement learning, there are going to be some kind of past experience. All the decision is taken based on the data. Okay, that's the major difference. Whereas in MDP, it's an assumption. So let's see next one. Solves for optimal policy using dynamic programming, whereas it learns optimal policy through the trial and error method. Okay. In MDP, we will be using something called as a dynamic programming (DP), whereas in reinforcement learning, we will be using trial and error method. That is permutation combination in order to get the optimal result. Okay. Hope you guys are able to see the difference, guys. It's a very important thing. Okay, both are sounds good, sounds same, not good. Okay, because one is an ancient method, one is a new method. How it differs? That's the major thing that you guys need to understand. Okay, so yes, sir. Over to you.
Yeah, reinforcement learning and MDPs. So let's see what is the difference here. So RL algorithm learn optimal policy by interacting with the environment and receiving rewards. Okay, and it is gamified model, right? It is based on gamification. Then core nature and logic is gamification. The agent learns maximize reward by exploiting the environment. If you see the Mario game, what example he has given, or if you see Go game, or you see any game in the world, it is based on reward. Like somebody will win lose, right? Reward system. Whether somebody will get something or somebody will lose something or will not get. So updating the policy based on the experience. So MDPs assume known transactions, probabilities, and rewards. So solve the optimal policy using dynamic programming, and reinforcement learning learns transaction possibilities, rewards from experiences, and learns optimal policy through trial and error. So that's how childrens learn, right? They learn trial and error. They keep learning, doing trial and error, and keep learning. And that's why um, we human beings actually do reinforcement a lot of times to learn all the skills. I think we do it with language, we do it with play, we do it with subjects, we do it with everything. Whatever we call creativity, actually it's trial and error, guys. Or if you see, we do iterations, or we keep doing, like when you suppose you are making a painting, right? World class painting, so you do a lot of trial and error, then it is crafted, right? Or you're making a pot, so you're doing reinforcement learning. So you can relate reinforcement learning like trial and error kind of learns optimal policy through. So here it looks like fancy optimal policy. Okay, policy, you need to understand the way something learns, the optimal policy, like what is the best way to do something, some optimal action. Okay, trial, through trial and error, you keep doing that. And in MDPs, it is like optimal policy using dynamic programming. This is main difference. So keep learning. Let's move to the other section.
Sure, sir. Let's move on. Okay. Yeah, let's see the limitations and challenges of MDP. While MDP offers a powerful framework, they have limitations and challenges, especially when applied to real world problems. These challenges include dealing with a larger dataset, larger action spaces, handling continuous states and actions, and managing uncertainty in the environment. Let's see one by one. Okay. First is complexity. Solving MDP can be computationally expensive, essential for a larger scale problem. The computer complexity of the algorithm depends on the size of the state and action spaces. So yeah, if you are having larger space, we have mentioned right in previously, because in Super Mario game you will be having lots of world, so you're gonna get lots of frames and lots of action is gonna be there, so it could be complex and the resources gonna require is very complex. Uncertainty. Real world problem often involves uncertainty which can be difficult to the model to model and account for the MDP, because like MDP is a mathematical approach. It is not like a learning from a past experience doing something which is different. Okay, no, it's a mathematical model. So for that, uncertainty is it's gonna be there for a real world program. For Super Mario is not a real world program. It's like a game. We know all the steps what gonna occur. Then it's a gamified thing, but it is already known. But in a real life situation, you are just creating a robot kind of thing. There are going to be some uncertain situations going to be occur, but this MDP cannot able to handle that because it's a formula. End of the day, MDP Markov Decision Processes is a formula. It's a mathematical thing. It's not going to learn from a past experience, right? So it is uncertain. Next, generalization. MDP often struggle with generalization to the unseen states and actions. The learned policy may not perform well in the situation that differ from the training data. Yeah, you cannot apply MDP which you applied for the Super Mario to the game the sir is explaining, that chess game. You cannot apply the MDP of the chess game to the Super Mario game because like both are completely different environment, because it's a formula. End of the day, it's a formula. Okay, so these are the limitations. So it is complex, it is uncertain, and it is generalized. That's the reason we will be going for reinforcement learning. It's a new way of Markov decision process. Okay, yeah, that's all about the limitation challenges of MDP. Yeah, sir. Over to you.
Yeah, so limitations and challenges of MDPs. So while MDPs offer powerful frameworks, they have limitations also. Challenges especially applied in real world problem, like challenges including dealing with large states and action spaces, handling continuous states and actions, mapping uncertainty in the environment. So complexity is solving MDP can be computationally expensive, especially for the large scale problems, and complexities of algorithm depending on size and state of the state and action space. So these are very important aspects. It helps in like complexity. The MDPs will help, but uncertainty is like in uncertainty. Can we go a little up? And yeah, so yeah, so in uncertainty, the real problems are like real world problems. You need to you often involves uncertainty, which can be difficult for model accurate because it is a mathematical model, as Raja already mentioned. So their reinforcement learning works. That's why human beings have developed this reinforcement thing, because we always from millions of years we have learned through reinforcement learning, guys, and this is how we have been learning, and that is the best optimal way to learn things, and that is why MDPs will not work, because MDPs are based on certain algorithm which has certain limitations, which is a mathematical model. But for reinforcement learning, it's a very organic way of learning through the experiences which we human beings have developed the capabilities. Generalization, MDPs often struggle with generalization to unseen states. So that is why reinforcement learning is better there, and the learn policy may not perform well in situations like differs from the training data set. So that is why and generalization is the way we have optimal model. If you have learned in the past sessions, so our model should be optimally learned, so that it can make generalizations, so that it can learn from the real world data and unseen data, and it should not be overfit or underfit. Okay, let's move to the other section.
Okay, let's move on. Okay, yeah. What are the applications of MDB in data science? So we are already explaining the application, man. Okay, guys, we are just explaining the applications only. Okay, one is Super Mario game, another one is chess. Okay, let's see what are the other applications that we are having. MDP has a wide range of applications in data science, including robotics, autonomous system, recommendation system, and healthcare. They are used to optimize decision making process, predict the future outcomes, and enhance the performance of various systems. Let's see what are they. Robotics, path planning, object manipulation, and autonomous verification. I hope everyone can able to understand. Recommendation system, personalized recommendation for product, contents, or services based on user preferences. Healthcare, optimize the treatment plans, managing chronic conditions, and improving patient outcomes. Yeah, those are the things. Financial modeling, predicting stock prices, optimizing investment strategies, and making risk managing risk. Sorry. Okay. I hope like you guys are able to understand. So whenever we are having a kind of patterns, right? We can use this MDP formula in order to make the decisions. Okay, it not only just robotics, recommendation system, healthcare, and finance. N number of application, n number of fields, whichever you need AI, we can use this MDP as a fundamental. We can build the reinforcement on top of it, and we can get the business success. Okay, so yeah, this is all about the applications of MDP in data science. Yes, sir, over to you.
Yeah, so application of MDPs in data science, AI, ML, guys, there are vast applications to use for optimization of decision making processes, predicting future outcomes, enhancing performance of various systems. So we use in a robotics, path planning, as I already mentioned, the Mars rover. It was when planning was not there, so it will stop for every action. Like if it finds any difficulty, it will. So then once it was planned properly, then with reinforcement learning, so it will make decisions itself. And then object manipulation, autonomous navigation, we use it for self-driving cars, recommendation systems. Amazon uses it for products, content, services based on the user preferences. Then healthcare, optimizing treatment pains, okay, managing chronic conditions, improving patient outcomes. Financial modeling, predicting stock prices, optimizing investment strategies, and managing risk. So these are the applications, and n number of wherever you find uh, uh, these kind of like things where you can use these algorithms, so you can apply in n number of industries according to the objective function and also the characteristics of the data. Let's move to the other section.
Yeah. So guys, that's it all about this MDP. Hope you guys have enjoyed Markov Decision Process. If you guys have any doubt, just ping in the comment section. We will take up and we will solve your doubts. Okay. So until next session, bye guys. Take care. We will all meet in the next session. Bye guys.
Bye, guys. Keep learning deeply. If you have come to this session, go and watch all the sessions 5 to 10 times. You do reinforcement learning. Now you know why you have to do reinforcement learning, because that is the human nature, the way we have learned from millions of years. We use reinforcement learning in everything, trial and error. We have learned and we have reached here. So keep learning deeply with long-term objective function and patience, consistency, persistency, and perseverance. Keep learning deeply. So let's move to the other session. Thanks. And give us feedback for each session. So we want to be continuously improve each session and the experience you're having with us. So subscribe to our channels. Also press the bell icon so that you will get notification on time. Keep learning deeply and absorb the information, digest the information, and apply the information. Do all the quizzes. There are live thousands of quizzes, and also the assignment. Mimic and imitate the assignments and the projects. Keep learning deeply with long-term objective function of your career. Become a lifelong learner. Now degrees and all those things are not going to matter. Continuous learning is the only way. Keep learning. So let's see you in other session. So thanks.